So second video here, we're going to talk about reference angles. So it says find theta if the terminal side of theta goes through the point -3, -2. Well, the point -3, -2 is down here in quadrant number 3, which then means that my line is going to come through here. Okay? Theta is going to be all the way around here. That's going to be my theta, the angle that I'm looking for, because over here is my 0 degrees or 0 radians. Okay? But in order to find that, I've got to use a reference angle, which is right there. Because the reference angles, remember, always come off of the horizontal axes. Okay? Which you should have gotten in video number 1. So let's break out that one. So there's my horizontal. So this is 3 because it's really -3 over here, but we're dealing with distances, so we can make that be positive. This distance down here is -2, so really this is 2, and I'm looking for my reference angle right there. Screaming out tangent. So the tangent of theta prime is going to equal 2 divided by 3. So theta prime, then, or my reference angle, is going to be the inverse tangent of 2/3. Okay? So let's find that on a calculator. So if I go to my calculator and I go, first I get rid of all this craziness, the inverse tangent of 2/3 is going to give me that, but that's in radians. If I want to make that be degrees, I convert it. Okay? So in my reference angle, in degrees is going to be 33.69 degrees, or my reference angle is going to be 0.588 radians. Okay? But that is this angle right here. I want the whole angle, so I've got to add 180 degrees to that. So theta is going to be my reference angle plus 180 degrees. So that would be 33.69 degrees plus 180 degrees. So theta would be 213.69 degrees. In terms of radians, theta would be pi plus my reference angle. So that's going to be 3.14-ish plus 0.588. So that's going to give me my theta here of 3.730 radians. Okay? Major point. Reference angles come off of the horizontal axes. Okay? So, it's asking us to find our reference angle. Theta prime is our reference angle. Okay? So the first thing that I'm going to do is I'm going to say to myself, 125 degrees is going to be, there's 90, and I'm going to keep going just a little bit more, and it's going to be up in here. Okay? So this is 125 degrees. More than 90, less than 180, puts me in quadrant 2. So I need to find theta prime, which is that angle right here coming off of the horizontal. Okay, so that tells me then 5 more gets me to 130, 50 more gets me to 180, so my reference angle here would be 55 degrees. If we give you the problem in degrees, you can give us the answer in degrees. If we give it to you in radians, give it to us in radians. Okay? Here then, 220 degrees is more than 180, but less than 270. So it's somewhere down here. So that's 220 degrees. Well, that my reference angle is going to be in here because it comes off of the horizontal. So in this case, it would be 220 minus 180. So my reference angle here is 40 degrees. Okay. Third one, 310 degrees is somewhere down here. So my reference angle is here. So that's going to be 360 minus my theta, which in this case was 310. So my reference angle is going to be 50 degrees. Okay? Now, what we're asking you to do is look under here once we finish those. So it says, compare the sine, the cosine, and the tangent to theta as to my reference angle. Okay? So, here in number 1, my sine of theta was equal to, if I type it in on a calculator, the sine of 125 degrees is 0.8192. The cosine of theta is going to be negative 0.5736, which makes sense because the theta angle is in quadrant number 2. Quadrant number 2 has positive sine values, negative cosine values. And the tangent here of theta is equal to negative 1.4281. So that's my theta, my 125 degrees. Now let's compare the sines of theta prime. So the sine of theta prime is equal to 0.8192. The sine of 55 degrees is the same, which makes sense because we're in quadrant 2. So these two in quadrant 2 should be the same. The cosine of theta prime, so the cosine of 55 degrees is positive 0.5736, which should be making some sense because these two should be opposite because we are in quadrant number 2. Negative signs, or negative cosines, excuse me, according to my reference angle. They should be opposites. And the tangent of theta prime is 1.4281. And those also should be opposites. Because we're dealing with quadrant number 2. Okay? Let's look now here at number 3. Let's compare the sines of theta. So the sine of 310 degrees is negative 0.7660. The sine of my reference angle, which is 50 degrees, should be positive, and it is, because now I'm in quadrant 4, so I'm looking, my reference angle is always going to be acute, so my reference angle is always going to be in quadrant number 1. My actual angle is in quadrant number 4, so those, because we're reflecting now across the x-axis, those should be different. When I look at the cosines, those should be the same. The cosine here of theta is 0.6428, and the cosine of 50, which is my theta prime, is 0.6428. Again, I'm just typing these in on a regular old scientific calculator. Okay? Now, because the sine was opposite and the cosine was the same, the tangent of theta and theta prime should also be opposite. So the tangent of theta is negative 1.1918, and the tangent of theta prime is positive 1.1918, because of where they fall on the quadrants. Okay? So when I'm in quadrant 4, then, I don't know why it keeps jumping like that on me. So when I'm in quadrant 4, sine should be opposite. Cosine should be the same. And tangent should be opposite. If I was in quadrant 3, sine should be opposite. Cosine should be opposite. Tangent should be the same. Okay? And that concludes video number 2.